Hi, everyone. We'll get started in about 2 minutes. Okay, it's 6 o'clock and we'll get started right now. So last time we left off at slide 33. Now we're going to talk about GCF, which is greatest common factor. All right, so 3 is a factor of 12 and -3 is a factor of 12. This is because if you divide 12 by 3 and -3, you guys will get an integer. And that's how you know if a number is a factor of a number. And only perfect squares have an odd number of factors. And this is because one of the factors are duplicated, such as 4. The factors are 1, 2, and 4, and you multiply 2 times 2. So there's 2 2s. That's how you get 4. And same thing with 9 and 16. You have 2 3s and 2 4s. And here's GCF, greatest common factor. So here are the factors of 12, 1, 2, 3, 4, 6, and 12. And here are the factors of 6, 1, 2, 3, and 6. If you see here, there's a lot, they have a lot of common factors. They have 1, 2, 3, and 6 in common, but the greatest common factor is 6. And this is pretty similar to LCM. So you would write it as GCF brackets 12 and 6, and it's 6. And how to find GCF, you do it by prime factorization. It's pretty similar to how you find LCM. If you guys remember for LCM, you would find the prime factorization, and you will find the numbers with the greatest power in both numbers, and then you multiply them. Well, for GCF, you find the smallest power. So, for example, the 2, both numbers have a 2 power, but the one in 360, 2 to the third, that is the smaller power. So you will multiply that. And then you have a 3 too. But in 48, the power of 3 is smaller. So you will multiply that also. And there's no 48 doesn't have a power of 5, so you don't multiply by 5. So it's just 2 to the third times 3 to the first, and that's 24. That is the greatest common factor of 360 and 48. And GCD stands for greatest common divisor, but I've mostly heard greatest common factor, so I'll just call it GCF. But these are the same thing. And if two numbers don't have any prime factors in common, then their GCF is 1. So for example, 2 and 3, they don't have any common factors besides 1 in common. And this is also pretty similar to LCM. 500 and 300, you want to find their GCF, and then you want to find the GCF of 2 times 500 and 2 times 300. Well, you can, this is just GCD of 500 and 300 times 2. So pretty similar to the LCM rule we covered last lesson. So to simplify it is GCD n times A, n times B equals n times the GCD of A and B. And here's some challenge problems for you guys. So 6 pairs of numbers. I want you guys to find the GCF of all pairs and get started.
Are we gonna do the Quizlet today?
Yeah, we will.
Yeah. So. Okay.
Okay, I'll give you guys about 2 minutes. Oh, and you guys can use a calculator if you guys want. Once you guys get to like higher math, you guys are gonna need to use a calculator all the time. Okay, a few more seconds if anyone else wants to type in answers. Okay, so I'll go over the answers right now. So the first one, GCD of 32 and 48. So you guys can factor out a 16 in both of them, and that's your answer. GCD of 99 and 100. They don't have any common factors besides 1, so that is the GCD. GCD of 315 and 108. The answer is 9. If you guys don't really know where to start, you guys can divide 315 by 5 first, and then keep breaking it down further. And then 108 can be divided by 2, and then or 4, and then just keep breaking it down more and more. And GCD of 99 and 726, the answer is 33. You guys know 99 is can be divided by 33, And you guys can test if 726 can be also divided by 33. GCD of 365 and 1985, the answer is 5. And because they can both be divided by 5. And the GCD of 9,009 and 14,014, the answer is 1,001. Again, you guys know 9,009 can be divided by 1,001. And then 14,014 can also be divided by 1,001. So that's your answer. So to find prime factorizations, just start with what number you know. Like 365, you know, it can be divided by 5. And then if you divide it by 5, you get 73. Yeah, you guys get 73, and 73 is a prime number, so you can't break it down any further. And that is it for this unit, which means we're going to play Quizlet right now. And after that, we'll start with unit 4.
You said Kahoot.
Yeah, well, our TA Emily made Quizlet for this unit, but we'll play Kahoot for the next unit.
Oh, okay then.
Yeah. So thanks Emily again for making these Quizlets and Kahoots. I'll put you guys in teams this time. I don't think you've done that yet.
结果你要打开它的那个，你才知道去哪。
Is this last one? Can you share the link?
Yeah, the link. Yeah, it's right here. So guys, just log into www.quizletlive and then just type in the code.
Yeah, I mean, like, can you like just share the link into the chat?
Yeah, I can. Well, there's not really.
Chef. And
Okay.
go over lake.
写一下一会儿。
Yay! Wait, put the overlakers together. The overlakers together.
number 写上去。
I put the what?
Overlakers together. Me, Aiden, Alexandra, and Ethan. Where's the?
The teams are random, I think. I don't know if I can choose teams.
If I'm with one overlaker, I'll be happy.
它这里有那个 website， 你自己看。你这个看不见，所以你得把它抄下来。
Can you guys please stay muted? Please.
I'm eating my dinner. How did it work?
你这样比较慢，因为你是重新 search 的，它这里已经给出了那个 link， 你直接把那个对啊，把它打进去不就行了吗？
那可是多难呀！那非得，那为什么不能send到chat？
I guess I can't do that. Yeah, I don't know how to remove myself, so I'll just play with you guys.
I think you
All
just click on your
can't
name.
answer any questions, okay? You can't answer questions.
Well, I have to if I'm on a team.
No.
Well, if I leave, I can't start the game. So.
This is very sad.
All right, we got 9 people, including me. Anyone else want to play? Or yeah, if I stop sharing the screen, I don't think that's gonna do anything. I'm still gonna be in the game. All right, any last call? Anyone else?
Just share the link.
Yeah, I need to join.
Okay. Here's the link if you guys want it.
Anybody else? Let's see. Oh,
There was one more person, so I don't know.
we need 10 more people. This is like, wait, what's Bellevue Overlake?
That's me.
Let's go. Good. Thank you. Thank you for being an Overlaker. Go Owls.
What school did you used to go to?
I used to go to Overlake.
Like before you came to Overlake.
Einstein Elementary. It was a real.
Yeah.
All right, I don't think anyone else is gonna join. So,
Wait, do we have to play?
oh, you don't have to.
Wait, can you kick me out? Because I don't really want to play.
Yeah, I see that. Okay, we'll start.
Yes, I'm on your team, Ethan.
Yay.
Huh?
This is confused.
Oh, I get it. My bad.
This is confusing.
Can you restart?
What?
I don't think I can.
Can you? Oh, you can't. Wait, can we?
What is
All right,
happening?
so whoever has the right answer, you guys click it. Like your teammates might have the wrong answers in there.
We do the typing thing.
Wait, can we like do another round of this again?
Yeah. I don't know if I can stop it right now though.
3, no.
Restart or something.
I don't know what the iPad is. This is like 上课的嘛，
Yes.
上课的 iPad。
How does this work?
All right,
What?
so one person on your team has the right answer. The rest of you guys have the wrong answers. So just make sure you have the right one.
How do you
And I think if you get one wrong, you guys go back to 0.
use?
What?
You can't type anything. You just have to guess.
You multiple choice?
I know, but
Oh, you can't type?
I don't even have the answer.
Ouch.
Wait, honestly.
I think we should have done individual.
Yeah, we should have done individual. This is so confusing.
Yeah, it is. Are you guys still playing?
Oh. This is so,
Dude, it was 10.
yeah, but I don't have 10 on mine.
But then maybe it was mine. Erg. Ouch.
Yeah, can you guys leave the game? I'm not in it anymore. I'll just do individual.
Yes, please.
Fuck, we're just clicking wrong answers. It's getting really dumb.
Yeah, this is just like, this is so weird.
Yeah, all right.
Someone press 10, please. Anybody has 10? Please have 10 someone.
All right, here's a new game for you guys.
Yes, I'm leaving. Everybody leave. Quizlet. Live. 76981. Chef. A Jeff. A Jeff. So, Jeff.
All right, here's a new game link.
Copy game link. Okay. Who's Owls? I bet that's Ethan.
I changed my name. Because why did you change your name to A Jeff Chef?
Because my nickname is Jeff Chef.
Jeffrey.
What?
Is that Ethan a person who's going to be coming to Overlake? Because I don't think he's in Overlake.
Yeah, he's coming to Overlake.
Okay, that makes more sense now.
You're on my math team, Ellie. You should know. We could have actually won the contest if we had one more team or more.
Yeah, that's quite outmatching.
We were like the number one in our like room, but like there's too many people. Can you create it?
All right, last call. Anyone else?
Anybody else?
Jeff Chef. Wait, why is your nickname Jeff Chef, by the way?
I don't know. I had it since like first grade.
All right, no one else.
Because it rhymes, probably.
If I'm leaving you out, please shout, or so I don't leave you out.
Huh?
All right, I'm starting.
Yes, I'm Camel. I am.
T-Rex. That's a little bit weird.
I think I should see you. Shoot.
And some of these might have like the same answer for 2. I'm not sure how that's gonna work, but we'll see.
How many Quizlets can we play?
This is only one for this unit. One per unit.
I want to play.
Yes, let's go. Click to continue to stats. What does that mean?
If you want to see stats, I guess.
What's that? Oh. Okay. This is my third time.
All right.
I'm so happy.
What was the game you suggested last time?
All right, let's get back to our lesson. All right, so we're done with this unit. All right, for unit 4, we're going to be talking about fractions.
Math lesson.
All right, so I'm assuming all of you guys know what fractions are. Here are some pictures to help you see what fractions are. So the whole, here are some circles. So the whole circle color, that's 1. It's a 1 whole. And then half of a circle, that's 1/2, 1/4, and then 3/4. You guys can see that visually. So the top number is the numerator. The bottom number is the denominator. That's what we call them. And 0 cannot be in the denominator because fractions are like division. If you divide anything by 0, that's not possible. So you guys can read this as 1 divided by 2, 1 divided by 4, 3 divided by 4. It's pretty similar to division. And here's a fraction number line to help you guys compare. So 0 to 1, 1/8, 2/8, 3/8. The scale from 0 to 1 is divided into eighths, and divided into 6/4, thirds, seconds. So remember, if the numerator is smaller than the denominator, it's always going to be smaller than 1. But if the numerator is bigger than the denominator, then it might be bigger than 1, or it might be bigger than other whole numbers, such as 2 or 3. All right, multiplying fractions. So this is pretty easy. Well, it is easy. So multiply the numerators and multiply the denominators. That's all you got to do. So for example, 1/3 times 1/2. That's just 1 times 1 and then 3 times 2. So 1/6. 2 times 1/3. So if you see a whole number like this is really 2 over 1. So there's an invisible 1 in the denominator. So 2 times 1 and then 1 times 3, that's 2/3. So multiply the top, multiply the bottom, and then that's your answer. And then here's the rule generalized at the bottom. So A times C on the top, and then B times D on the bottom. And if you have really big numbers in the fractions that you guys are multiplying, you guys can break them down into their prime factorization and then cancel out to make it a lot easier. So for example, 15 over 99 times 693 divided by 693 over 105. So those are big numbers. You guys don't want to multiply them straight out. You guys want to break them down first and then cancel them out. So 15 can be broken down into 3 times 5, 99 to 9 times 11, and so on. And then if you multiply these, you guys can cancel them out. So you guys look at this whole thing on the top and the whole thing on the bottom. So both the top and the bottom have a 3, so you cancel that out. So 3 divided by 3, that's 1 and 1. Both have a 9 and an 11 and a 5. And a 7. So these should be the same. Yeah, these are the same on the top and bottom. So this would turn out to be 1. So remember, just break it down. Really big numbers, break it down into prime factorizations and then cancel out from the top and bottom. So if they have the same term, same number, same factors on the top and bottom, you guys can cancel it out. And then here's a visual representation of what multiplying fractions look like. So here you have 2/3 and then 3/4. And if you multiply it, the answer is a dark blue region, 1/2. It's kind of like 2/3 of 3/4, and then that's 1/2. Okay, and here are some challenge problems. And then once again, type your answers into the chat, and I'll answer any questions. And I'll give you guys about 7 minutes to do these. And you guys can use a calculator if you guys want. I'm not too picky. Wait, actually, no, don't use calculators for these. I want you guys to practice breaking them down. Someone raise their hand.
Well, that was just an accident.
All right, about 2 more minutes.
What time will we have break?
I'll give you guys a break. Around 7, I think.
Thanks.
Okay, I will go over the answers right now. All right, I'll start over here with the bullet points. So from top to bottom. So the first one, 6/5 times 4/9. Just multiply them, and you guys get 24/45. And you guys can simplify them also to 8/15. We'll do simplifying later, but right now you guys can just leave it as the numbers you guys get. -1/3 times 2/5. You guys should have gotten -2/15. Next one, 3/7 times 7/8. You guys should have gotten 21/56. You guys could simplify that one also. You guys can take out a 7 from top to bottom. 13/200 times 7/8. You guys should have gotten 91/1600. And then the last one, -9/5000. All right, over here, 5/6 times 11/7. That answer is 55/42. And over here, 1/5 times -75 times 2/3. The answer is -10. So for this one, I would have multiplied 1/5 by -75 first, and then multiply by 2/3. That would have been the easiest way, I think. Or you guys could have done it anyway, I guess. So it doesn't really matter. And the last one, for this one, you guys should have broken it down and then multiplied after you guys broke it down. And the answer is 70. So both the top and bottom. So the top has a 14 and the bottom has a 7. Well, you guys can divide that. You guys can take out a 7 from both. So this will become 2, and the 7 will become a 1. 63 and 9. You guys can also take the 9 out. So this will become 1, and this will become 7. And then you guys can also take out a 16 from 80 and 16. So 80 divided by 16 is 5, and then this will become a 1. So really, after you guys broke it down, it should have been 5 times 2 times 7, which is 70. And there's 2 negative signs, so a negative and a negative is a positive. So this answer will be positive. And yeah, it is 3/8 for number 3. That's after you simplify it. So dividing fractions, this is also very easy. This is practically the same thing as multiplying fractions. So a divided by b, remember, multiply by the reciprocal. So dividing is like multiplying by the reciprocal. So a divided by b is a times 1 over b. And then 1 divided by the fraction a over b, that would become b over a. So this is really just 1 times b over a. And at the bottom here, this is dividing fractions. So a divided by b, a over b divided by c over d, that becomes a over b times d over c. So here's, you flip it. So here's a reciprocal and you multiply by the reciprocal. So a times d over b times c. And when you guys see letters or variables together like this, this means you multiply them. You don't just combine the digits, you guys gotta multiply them. So a times d and then b times c. So remember, multiply by the reciprocal. All right, so what number times 2/5 equals 32? So this is what you guys are gonna do in algebra. You guys are gonna try to find any number in the equation, not necessarily just the answer, such as 32. You guys are gonna have a missing term here, and you guys are gonna have to try to solve it. So to solve this one, divide each side of the equation by 2/5. So in algebra, if you guys want to solve for a term or a blank space like this, you guys got to do the opposite. So what I mean is, so 2/5 times the blank space. If you see times, you got to divide. So divide each side by 5 over 2. No, divide each side by 2 over 5. And then this becomes 32 times 5 over 2 on this side. And then 2/5 divided by 2/5, that's just 1. So this side is just 1 times the blank space, which can be represented by a variable such as x or a. So this side is just the variable. And then this side is the answer. And yes, it is 80. So that's how you guys solve for missing terms. And here are some challenge problems for you guys. And then at the bottom here, I want you guys to find what A represents. So remember, these all have multiplication on the right side. So what you guys want to do is divide each side by the fraction. So that's how you guys solve for A. And then I think I'll give you guys a break after this.
Can we shout out the answers now?
A few more minutes, like 2 more minutes.
What?
Okay, so I will go over the answers right now. Let's start with the top here. So 3/5 divided by 2, that is just 3/5 times 1/2, and the answer is 3/10. Over here, 7 divided by 7/8, that is 7/1 times 8/7, and the 7s cancel out because there's a 7 on the top and the bottom, so the answer is 8. Over here on the right, 14/3 divided by 5/4, that's 14/3 times 4/5, and the answer is 56/15. Negative 5/6 divided by negative 12/7. The negatives cancel out, so it's a positive answer. And then this is 5/6 times 7/12, and that's 35/72. And then 40 equals 2/3 times a variable, or x or a or blank. So here you divide each side by 2/3. So 2/3 divided by 2/3, that cancels out. So that's 1. So, and then 40 divided by 2/3, that's 40 times 3/2. And that answer is 60. So the variable here is 60. In the bottom, find a. So 30 times 4 over 5, divide each side by the fraction, and then a equals 37.5. And then I just made these numbers up, so that's why some of the numbers might be kind of weird. 56 divided by 2 over 7, which will give you a, and the answer is 196. 74 times 5 over 3, the answer is 123 and 1/3. 45 times 1/2, no, 45 divided by 1/2, that's 45 times 2, and the answer is 90. And then 23 divided by 3/4, which will give you a, and the answer is 30 and 2/3. All right, so I'll give you guys a break right now. I think like 7 minutes. So meet back here at 7:03, and we'll continue from there. A face reveal? You guys already know what I look like. All right, you guys don't seem to have any questions in the chat, so I'll just let you guys go public in the chat. All right, have fun. Yeah, try your best not to lag the chat. I don't know if that's possible. If this Zoom call crashes, it's because of you guys. Just to let you guys know. You guys are great at spamming. Just to let you guys know. All right, 2 more minutes and I'll close the chat down.
我擦好了，这个已经出来了，那我把你屏幕擦一下。Stop it！ 干嘛？他们干嘛？他们这什么在干嘛 ？Spamming 啊 ？Who's spamming？ 快结束了吗？ But only 88 notifications. I am disappointed.
All right, 7:03. I'm shutting down the chat. All right, stop spamming. All right, stop spamming, guys. All right, so let's continue. Raising fractions to exponents. We already covered this in the exponent unit. This is the same thing. A over b to the n is a to the n over b to the n. These are all the same rules, same thing. I don't know why the book covers it twice, but I'll just put it here as a reminder. So same thing as raising a quotient to exponents. Fractions are basically quotients. And simplest form of a fraction, you guys already, some of you guys already know how to simplify. It's easy. A fraction is in simplest form if the numerator and denominator have no common factor besides 1. For example, 2/4 can be simplified to 1/2. 2 and a 4 have a common factor of 2, so take that out, and then you guys get 1/2. And then here's another example down here, 12 over 30. You guys can take out a 6, so that's 2/5. And then these are the same value. So 2 over 5 is the same thing as 12 over 30, just different numbers. So to simplify a fraction, again, find common factors, cancel those out, and then your answer is, your simplified fraction is whatever you have left. Here's some more examples. At the bottom, 225 over 540. It's a big number. You guys should use prime factorization in this case. So break it down into its prime factorization. 3 squared times 5 squared over 2 squared times 3 to the third times 5. And then you guys can cancel out. You guys will notice that each, the top and bottom have 3 squared times 5. For example, 3/3, 3 to the third, you guys can take out 3 to the second, and you guys are left with a 3. Same thing with 5 to the second. You guys take out a 5, and you guys are left with a 5. So cancel this out in the parentheses, and you guys are left with 5 over 2 squared times 3 times 3 squared times 5 over 3 squared times 5. Yeah, this is already canceled out. So you guys are just left with this, and then that equals 5/12. So 5 over 12 is the same thing as the original, 225 over 540. Same value, just represented with different numbers. Or in math terms, it's a different proportion. It's the same proportion. That means they're equal fractions. So here are some more challenge problems. You guys got 8 problems. I'll give you guys about 5 minutes to do these. I want to try to get ahead in the lesson. So just do as much as you guys can. And then if you guys have any questions, I'll answer them. So remember, find any common factors in the numerator and the denominator, and then cancel those out. My bad. Thanks, whoever's doing the problem on the screen. Don't give away answers. All right, 2 more minutes. Oh, now I see the disable participants to annotate. I don't know why I never saw that before. All right, that solves that. 1 more minute. Okay, it's 7:12, and I'll go over the answers right now. All right, so starting with the top left, 36 over 27, you guys can take out a 9 from the top and bottom, so that will leave you with 4 over 3. 256 over 304, that leaves you with 16 over 19. You guys can take out a 2 and then keep going after that. 4,800 over 12,000. All right, so you guys can take out 100 from both the top and bottom. So that becomes 48 over 120. And then break that down further, and you guys get 2/5. 1260 over 1008. You guys can take out you guys hold. Yeah, you guys can take out a 9 and a 7, and then you guys can take out 2 from there, and then keep breaking it down, and you guys should get 5 over 4. 24 over 80 times 28 over 49. You guys can break this down into its simplest form fractions first. So this will give you, so simplifying 24 over 80 first, that will give you 3/10. And then simplifying 28 over 49, that will give you 4 over 7. Multiply those, and you guys should get 12 over 70. And that simplifies to 6 over 35. Negative 84 over 125 times 100 over 63. Again, you guys can simplify those. At first, well, you guys can you guys can put 100. You guys can switch the positions of 84 and 100. So put 100 over 125 and 84 over 63. That will give you guys negative 4 over 3 times 4 over 5, and then you guys should get negative 16 over 15. All right, bottom left, 400 over 39 divided by 1300 over 9. And remember, when you divide, you multiply by the reciprocal. So it's times 9 over 1300. So you guys can take out a 100 from the 400 and 1300. You guys can take out a 3 from 39 and 9. And that will leave you guys with 4 over 13 times 3 over 13. And the answer is 12 over 169. Yeah, no more spamming, guys. That time's over. All right, last one. 88 over 34 divided by 44 over 51. That's times 51 over 44. So you guys can take out a 44 from the 88 and the 44. So that leaves you guys with 2 over 1. And you guys can take out a 17 from 51 and 34. And that leaves you guys with 3 over 2. So it's 2 times 3 over 2, and the answer is 3 for the last one. All right, comparing fractions. So which fraction is greater, 3/5 or 4/5? That's easy. The answer is 4/5. Because when fractions have the same denominator, you guys just compare the numerator and see which number is bigger. So 4 is bigger than 3, or greater than 3. So 4/5 is the greater fraction. Which is greater, 3/5 or 7/10? Well, it's kind of hard to compare it with fractions with different denominators. So what you guys want to do is get the same, get the fractions that have the same denominator. Well, all you got to do here is multiply 3/5 by 2 over 2. So you guys get a denominator of 10, a common denominator of 10. So that becomes, so 3/5 becomes 6 over 10. And then you guys can compare the 6 and the 7, and 7 is obviously greater. Which is greater, 5 over 7 or 8 over 11? So you guys need to multiply both fractions for this one. So if the denominators look like this, they don't really have, one doesn't multiply into the other, or one isn't a factor of the other. You guys want to find the LCM, or least common multiple, of both the denominators. So the LCM of 7 and 11, the answer is 77. So you want to multiply 5 over 7 by 11 over 11, and 8 over 11 by 7 over 7. You want to multiply those. So then you guys get 55 over 77 and 56 over 77. So obviously 56 is greater than 55, so 8 over 11 is greater. And which is greater, -2/5 or -3/5? If it's negative, you guys want to see which number is closer to 0. So which number is smaller if it's when both numbers are negative. Because you have more of a, you have, this number is further away from 0, and this number is closer to 0. So -2 over 5 is greater. And then right away, we have more challenge problems. So I want you guys to find which numbers are smaller from each of these pairs. And then yeah, just type your answers into the chat and get started. I'll give you guys like 5 minutes for these. About 2 more minutes. All right, so I will go over the answers right now. So the first one, 3/2 or 7/5. The answer is 7/5. You guys want to have a common denominator of 10 for both because that is the LCM of 2 and 5. And you guys should have gotten 15/10 and 14/10, and 14 is smaller than 15, so 7/5. Next one, this one is obvious. One is positive, one is negative. The negative one is smaller. -2/5 or -3/5. I gave you guys the answer on the last slide. I didn't realize that. But yes, -3/5 is a smaller one. It's further away from 0. It's further to the left on the number line. 3/2011 or 3/2012. This is interesting because it doesn't have a common denominator, but it has a common numerator. And you guys can still compare fractions if it has a common numerator. So 3 over a lesser denominator or 3 over a greater denominator. The answer is 3 over a greater denominator. So the answer is 3/2012. If you guys aren't sure, you guys can test out extremes. So 1, you guys can test out 3/1 or 3/1,000,000. So 1,000,000 is greater than 1. Well, obviously 3/1,000,000 is a lot smaller than 3/1. So if 2 fractions have a common numerator, the one over a greater denominator, that one is a smaller one. All right, 19/30 or 22/35. For this one, 30 and 35 have a LCM of 210. So you multiply 19/30 by 7/7 and 22/35 by 6/6. And you guys should have gotten 133/2010 for 19/30 and 132/2010 for 22/35. So 132 compared to 133, 132 is smaller, so the answer is 22/35. All right, 506 divided by 101 or 509 divided by 112. You guys don't need to find any LCM for this one. There's a simple trick. This is kind of thinking outside the box. So 505 divided by 101, that's 5. And this is 506. So that means this fraction is greater than 5. 510 divided by 102 is 5. And 509 is smaller than 510. So that means this fraction is smaller than 5. Well, this one's smaller than 5. This one's greater than 5. So that means this one, 509/102, this is a smaller fraction. So for the last one, you guys kind of got to think outside the box, think of different strategies you guys might use. But most of the time, find find an LCM, find a common denominator, and then compare the two. All right, adding and subtracting fractions. So when you add and subtract fractions, you guys have to have a common denominator. This is not like multiplying or dividing. And multiplying and dividing, it doesn't matter what the numerator or denominator is. You guys just multiply them. But for adding and subtracting, you guys have to have a common denominator. So because you guys don't add the denominator, you guys only add the numerator. So for example, 2/7 plus 3/7, you guys just add the numerator. So 2 plus 3, that equals 5. And you guys keep the common denominator. So that equals 5/7. 1/3 plus 1/9, that equals 4/9. Because you guys got to convert 1/3 to have the same denominator as 1/9. So you guys multiply 1/3 by 3/3. So that equals 3/9. So 3 plus 1 equals 4. So 4/9. All right, same thing with -1/4 plus 3/4. They already have a common denominator. So all you guys got to do is add the numerators. So -1 plus 3, that's the same thing as 3 minus 1. If you guys remember from adding and subtracting integers. So that equals 2/4, and that simplifies to 1/2. And -2/3 plus 6. So you might at first glance, 6 doesn't appear to have a denominator, but it really does. This is actually 6/1. Whole numbers and integers always are over 1. So what you gotta do here is multiply 6/1 times 3/3. And that will give you guys 18/3. So 18 minus 2, that will give you 16. So the answer is 16/3. And here's a good rule to follow. Simplify fractions before adding and subtracting. You guys don't want to have really big common denominators. You guys want to simplify them down as much as possible. So then when you guys have to find a common denominator, the common denominator will be smaller than before you simplified it. So you guys always want to make numbers as small as possible or easy as possible to manipulate. Actually, we will save these challenge problems for next time. We ran out of time. So we will start here next time. And sadly for you guys, we are not going to be able to play Kahoot today, but we will play Kahoot next time once we finish this unit. So we will stop here, and I will see you guys next this Saturday again, same time, 6 to 7:30. So thank you guys again for joining us, and I'll see you guys next time.
What about Kahoot?
All right, bye guys.